Yeah, so as mentioned, this is a talk about security automation. So there are two things I have to say first. First, because this is about automation, this is very much an engineering talk, right? Because it's about implementing security tasks or automating them. And the second thing, I have about half an hour for this, which is not enough time for such a topic. So what I've done here is, this talk is split into two parts. Part number one is a very specific example of a security automation and implementation that I'm going to show here. And it should give you an idea what is possible and what can be done, because I think it does have a certain complexity level of what I'm presenting. And then in the second part, I'm basically taking a step back, looking at it from a broader perspective, and what do you need to build security automations, and what kind of tooling can I use for that, and what's the overall platform for that. But first things first, why security automation? That's my personal perspective. I think the problem with security is always you have a problem scaling, right? I've always worked in, let's say, tech organizations or software-driven organizations. The problem there is always the security team is much smaller than the engineering organization. And you might not only be dealing with engineering, but you also have to cover corporate security. So how do you deal with that? So the idea that I had about 2 years ago, where I started working on these kind of things, is to basically offload things which were done manually over to automation, for obviously freeing up time to do other things instead of these manual or repetitive tasks that you might not even enjoy doing. So having said that, as mentioned, I will start with a very specific example first. And that example is external attack surface monitoring or external attack surface management, in short EASM. How many people here are familiar with this term or maybe already using such a solution? Okay, there's maybe roughly five people. Okay, so I'm not aware of any dictionary level definition for what EASM is, so this is my attempt at defining it. First, as an organization, you have assets. A laptop would be one asset, but that's not really relevant here. The kind of assets that we're interested in here is everything that's facing the internet, publicly facing the internet. Examples for that are, for example, web application. That's the first thing that would come to your mind. But that's not the only thing, right? Look at this more from an infrastructure level. What is exposed to the internet is everything that has a public IP or a DNS name. That is, for example, the load balancer, where the applications are sitting by the load balancer, but it can also be a VPN gateway, for example. This is called the external attack surface because this is reachable to everyone on the internet. Now, the problem with that, or what might be a problem, these assets or the applications on those assets might have certain problems. On a more basic level, it's a CVE, like, for example, something that can exploited, remote code execution that can be exploited over the network. For VPN gateways or in general for appliances, that's something that happens more often than we would probably want to. But it can also be more basic things. For example, somebody installs some web application, some off-the-shelf application, and this application has a default credential for an administrative user, but whoever installed that software has not changed that credential. So that application is now reachable to everyone on the internet, and it still has default username and password. And the idea of the external attack surface monitoring is we want to be able to detect these kind of things automatically. Now, how can I do that? Or specifically in this talk, how can I implement that? Or what do I need? So let's first start on this from a conceptual level. First, this has multiple stages, right? The very first stage is I have to know what's my surface, or in that case, what are the public-facing or publicly routable IP addresses or DNS names of my assets. I have to somehow collect this information. The output of this stage is I have a large list of addresses. For example, this IP address, which is associated with a virtual machine, and some additional metadata information like this machine is on AWS cloud provider, or this machine is on an on-premise network like Office Network Munich and so on. Now, when I have this large list of addresses, the next question is this truly exposed to the public? Because just because he has a public IP doesn't mean it's really reachable, because it could still be firewalled, right? That means the next step is I have to perform a board scan to see if this is truly reachable from the outside world. The output of that stage is I have a subset now of addresses. Instead of this very large list, I have a smaller list now. And obviously, this is kind of a black box approach. I'm not making any assumptions. I'm just collecting these addresses and then try to find out what's hiding behind these addresses. After I have finished the board scan, I know what's really reachable, what systems. Then the next step that I can use here, for example, is a vulnerability scanner. This is nothing new. You can use something like Nessus, for example. The output of this stage is I now have a list of findings. For each address, I have a particular finding, like this IP address has now this CV or something like that, or particular web application vulnerability. Now, when I've done that, I have a large list of addresses with findings. But then the first problem is, okay, I have a finding for IP address 1234. Now, what system is that? I don't know, right? So I have to somehow correlate this back to the information I had in the very beginning. That's what I call joining of the results. So I have a finding for a particular address, and I'm correlating with the original metadata information from the very first step that says this finding is for this address, and I know this is a virtual machine sitting in this particular cloud account. Or this is a machine that is somewhere on an on-premise network in Munich or in Frankfurt or something like that. Now, when I have that, I have a large list of findings with metadata. I can publish this result somehow. Some people might want to push this into a SIEM system or some other system, but the idea is I'm somehow sending out alerts that notify me of any new findings. If there's no finding, there's no alert. If there's a finding, then obviously I will have an alert. Now, that's very abstract. So how can I actually implement something like this? The way I've drawn it here, the vulnerability scan can only happen after the board scan. The board scan can only happen after I've finished the address collection. And address collection, if I'm collecting data from different systems, this might actually run in parallel. In short, this is a workflow. And the best approach to implement a workflow is to use a workflow orchestration engine. The implementation I'm going to show now here is implemented using Argo workflows. Argo is a Kubernetes native orchestration engine, meaning that it's running on top of a Kubernetes cluster. Basically everything or every automation task is running inside a container. That's one way of doing it, but it's not the only way. So let's look directly into a specific example. So I cannot do a live demo now. What I've brought is a small video that shows what's actually happening here from a user perspective. So let me switch to the video. So I'm manually launching an ESM scan here now. This is the Argo submit command. So I'm sending it to Argo, which is in the background. The browser window shows you the web interface for Argo workflows. So what we see, I'm submitting Argo submit, and this will soon start a workflow. Yep, there it is. So we are going into the workflow now. So what we see here, top down, the workflow has been launched. There are circles. Each circle is basically one task in the workflow. What's happening here is blue means this is currently being executed. Yellow means this is scheduled for execution. Now, I've redacted a little bit, so don't be surprised. I'm collecting here data from 4 different environments, 2 cloud providers, 1 DNS provider. There's also a spreadsheet that contains address ranges from on-premise systems with metadata. Now, the address collection is pretty fast here because I'm using an asset database that contains this information. When I've completed all these asset data collections, then the next step is merging the results. So I have one big file with all the addresses that I'm building here right now. It's currently scheduled. Now, that was already executed. Now it's branching off. I have 2 things. The branch on the left, this is basically just taking all these addresses and publishing them on a spreadsheet just for reference to know what kind of external DAG surface do we have. On the right, the blue one that's already been started now is the actual board scan that's happening. Now, the interesting thing is, as I mentioned, this is Kubernetes native. So each task here is actually a container which is being executed here. That means when it's run as a container, I can actually look into the container and see the output, what's actually happening in there. So we go in and do that for the board scan. And what we actually see here is that we are performing a scan over almost 500 addresses. What you also see here is the output of the board scanner, which is Nabu in that case. Now, I don't have really time to show everything, and also the workflow as a whole takes hours, because I think the board scan is maybe 20 to 30 minutes, and the actual vulnerability scan is quite a few hours. So instead of waiting for that or going to the end of the video, I'll go back to the presentation and show you a screenshot of the finalized workflow. And that's what you see here. So the video was a top-down representation. What we see here is a left-to-right representation. So stage 1 to 4. Stage 1 was the address data collection. This is what we have seen in the video. So as mentioned, this is data being collected from an address database for two cloud providers, for the DNS provider with all the DNS names, and for basically a Google spreadsheet. There is a large list of network site ranges for the on-premise systems. The data is merged, and then in step 2, the port scan, what we still have seen in the video. And then afterwards, we are launching 3 different scans here. One is a Nessus-based scan. The second one is a Nuclei-based scan. And the third one is actually an SSH brute force, because I've seen situations where people just launch a virtual machine and they permit username and password authentication of that machine with a weak password. So I'm trying to find if there's instances of those as well. Each of these scan stages also publishes the results, and at the end, which is stage 4, I'm merging all the results and also publishing a report somewhere. Now, I would like to get into all of these details and show what's actually how this looks like from an implementation perspective, but I don't have the time for that. So instead, what I'm going to do, I'm going to show you one of these green circles, so one of the tasks, more specifically the Nuclei-based scan stage. As a reminder, this is running on top of Kubernetes, so everything is a container. And this is the entire script that performs the Nuclei scan stage. So as remember, we have an input and an output for this scan stage. The input is a list of addresses that we want to scan. The output is a list of findings. This is also what's specified here. So the input first in the beginning, which is the host port list, this is a container, so it's mounted inside the temporary directory. Same, there's an output. So when this task completes, Argo will automatically take this output file, Nuclei results, which is in the temporary directory, and make it available to the next stage as an input. And below that, we have a script, which is just a bash script, which is executed inside the container. And there are basically just 2 important commands. The first one is the Nuclei update template. Nuclei is a scanner that uses basically scan templates. So I'm downloading the latest set of scan templates with all the scan signatures, and then I'm launching the scan here at the bottom. What the scan here does is it takes the input, the host port list, which is a long list of addresses. It's going to launch the scan. And I'm also saying I'm only scanning templates that have medium, critical, high, and unknown severity levels. I'm not interested in the rest. The scanner is launched. It's running. It's writing the output, the findings, to this result file in the temporary directory Nuclei results. When the scanner is finished, this task is completed. Argo will automatically grab the result file and then make it available to the next stage. And that's it. It is basically like 10 lines of code, and that's an entire scan stage with Nuclei. The similar approach also applies to everything else that we've seen here before. Most of the things in the workflow are just a small collection of bash scripts with, I think at most, maybe 50 lines of bash script code. And that's it. You just have to stick it together the way you need it based on input and output information. Now, this is one scan stage. I said at the end, we want somehow collect these results and publish them also somewhere. And what's happening here, I've not taken a screenshot, but just the actual output looks very similar to that. If there's a finding that has a certain severity threshold, this is sent out to a Slack channel. So this suddenly pop up saying, hey, there's a new finding here for this particular machine. It also gives you the context information. Where is this machine located? What kind of machine is it? And description of the finding itself. And even better, if you also have an asset owner database, you can take this one step further. You can correlate the finding for the asset with the asset ownership. So you can automatically send out notifications as well to the owner saying, hey, there's this new finding. Please do something about it. And as mentioned, if there are no findings, you will not be bothered. If there are findings, you will see this popping up suddenly and maybe even send out automatic notifications. So I'm not even in the loop anymore. I know what's happening, but I don't have to deal with it anymore. This is the very rough overview of how it works. I mean, the idea is this is not very complicated. It just takes a little bit of time to implement it. Then you have something that's running automatically in the background all the time. Now, taking a step back, what are the individual building blocks that I need to build something like this? So as mentioned, the software stack here, Argo Workforce is in that case the relevant component here for the orchestration. Argo itself is running on top of Kubernetes, so I need a Kubernetes cluster. And I need container images with all the tools that I need. And on top of that, I have my scripts which implement the business logic or the automation logic in that case. If I don't want to use Argo, I can also use, for example, Dectome, which is also Kubernetes native, functionally very equivalent. But you can also use that, doesn't make a difference. If you don't want to Kubernetes at all, there's also other offerings, whether it's a cloud provider native offering, or use something completely different like Apache Airflow, which is also an orchestration engine. Either way, the idea is always to use a workflow orchestration engine to do most of the job. You only have to connect the dots, and that's it. Now, how are we triggering a workflow or an automation? The ASM example is something that you can do based on time, right? Like maybe once a week, once every 2 days, maybe even once a day. I want to trigger that and run it automatically. In Argo, that's called a cron workflow because you use a cron definition to define how often it's executed and when. But that is not the only way how I can do that. I can also launch it based on some external event. Something is happening and I want this external event to trigger a workflow or an automation. Argo itself does not support that natively, but there's an extension called Argo Events that allows me doing that. It can consume an external event and then launch a workflow based on that. So a specific example, there was a security incident at Okta, I think 2 or 3 years ago. Their support system had been breached. And the problem was their support tickets, or some of them, contain customer credentials, tokens to be specific. So the attack has breached their support system, they grab the tokens, and then probably try to move into the customer environments. The idea is a ticketing system can contain credentials and they shouldn't be in there. But how can I know that? So what I want to do here now is, I want to know when somebody created or updated a ticket or added an attachment, is there a credential somewhere in there? And this is something I can implement. So every time somebody creates or updates a ticket, the ticketed system can notify a webhook. Webhook is something that every ticketing system I know supports. So we create or update a ticket. The ticketing system will will notify the webhook with this information, which ticket has been updated or created. What we do next is we push out this webhook to a message queue. The message queue contains this information. Ticket X has been updated or created. And then the next step is, this is where Argo Events comes in. Argo can monitor this queue. It can see, oh, there's a new event, in that case, a ticketing information or ticketing system. It will grab that message, and then it will launch a workflow, which is ultimately triggered by this message. So what I can do then in the workflow, I can take this message, which contains information on the ticket. The workflow will contact the ticketing system and then grab the ticket itself with all the information or attachments it has. And then it will perform a credential scan over that. And if there's a credential in the ticket, I will be notified again. And I can respond to that. Like, for example, if it was uploaded by the customer, we will notify the customer. We can redact the credential from the ticket and so on. And this is just one example for an event-based automation where the trigger is not time, but rather an external event. In that case, a ticket being created or updated. And the time from the ticket being created until you have the notification is something that takes maybe at most a few seconds, and that's it. So you can respond very quickly here. There are more examples. In the EASM scan I had in the beginning, the address data collection was really fast. And that's because the data was grabbed from an asset database. This is one example for an automation. There are tools like, for example, Cloud Query. They can read data from external systems that have an API, like, for example, your cloud provider environments. So once a day, I can launch an automation there that uses Cloud Query to grab the data from my cloud environments, like the virtual machines, how are the networks configured, how do the firewalls look like, and we'll write this information into a database, for example. Cloud Query is very flexible here. You can write it in the classical SQL database, you can write it in the graph database, whatever you want. And then I have this information sitting there in the asset database. Now, when I have data in an asset database, I can actually now start implementing compliance checks with that. For example, give me all disk images that are not encrypted, or give me all firewall routes that are open to the internet and associated with a virtual machine. I have this data in the asset database, so I can just write a database query that actually identifies these kind of misconfigurations. This is something I can launch immediately after the asset data collection. So I have automated compliance checks as part of that. Yeah, the external attack surface monitoring I already mentioned. from a timing perspective, the asset data collection is something when you have the infrastructure in place, like the Kubernetes and Argo, you can implement this in maybe 2 days. The compliance checks is also just a matter of a few days. The external DAC service monitoring, depending on how many data sources you have and how many checks or scanners you want to use, it takes a few weeks maybe, but that's it. Some more examples. Yeah, the credential scans, we already mentioned the ticketing system, but that's not the only source. Some examples or problems I, for example, have to deal with are source code repositories, particularly those that do not have a CI/CD pipeline. So you don't know what's sitting in there, and this is also where I can do a credential scan. It's usually something what the CI/CD pipeline does, but if you don't have the pipeline, then you are somehow lost, and this is how you can basically force this on everyone. And it's a special problem for repositories that only contain scripts, and I've seen plenty of bash scripts that contain hard-coded credentials. And the effort for this is very small, and I can do this, for example, if I have a repository that has some activity in the last X hours, I'm going to scan it. Another example are the dangling DNS records. So what's a dangling DNS record? I have a domain, for example, example.com, and this domain is pointing to an IP address. Today, I'm the owner of this IP address, but tomorrow somebody is decommissioning that system, but they forgot about the DNS name. So the DNS name is still pointing to that IP address that I no longer own. So somebody else could grab that. The idea here is to identify these kind of dangling references. And when I have the DNS information inside the database and the asset information there, then this is easily doable by just, again, a database query. Give me all DNS records that point to something that's no longer in my database. That's a dangling DNS reference. Another example, user audits. That's particularly something that you have to do with certain compliance programs. For example, once a quarter, I have to check if permissions are still okay, so people do not have too many permissions. This is also something I can automate. In that case, I'm grabbing data from the HR system with the employees' information and which departments they are working for. On the other hand, I'm grabbing permission data from these different systems, and then I'm correlating this data. Like, somebody was working maybe in this department X last week, but now he's moved to another department, but he still has the old permissions, and he now has permissions for systems he should no longer have access to. That's something I can also automatically check now using this data correlation analysis. And this is also something I can do completely automated now with a very high fidelity rate. And that's not even everything. There's a lot more you can do. The only condition is whatever you want to do, first, it must be expressible in code, and two, you must be able to somehow grab the information that you need for doing so. So, to wrap up, first, can you automate everything? No, you cannot. It's not possible. But there are a lot of things that you can do automate. And the nice thing about the automation is, as a human, I'm not working 24/7. The automation is, though. It's always running in the background, doing these checks. And it's just alerting me if there is a finding. Now, another advantage of this is that I can increase the frequency of these checks. If I'm checking something manually once a quarter or once a month, I can now run it once a week or once a day or even once every hour or almost real time if you use the event-based launch. Also, something like the external DAC service monitoring, this is not something I can really do manually. I need automation in order to do that. And I think that's a nice thing. You can now do things that were not possible before manually. And the best thing, most of the things that I need to build something like this are available as open source. So I can just start from this with almost no cost associated with it in the beginning. And one last word of advice. When you want to implement external DAC service monitoring, it's very important when you're scanning data centers or service providers, you have to really check their acceptable use policy if you're allowed to do that. Usually you are allowed, but you have to notify them in advance that you're doing so. Like, hey, every Tuesday and every Thursday I'm going to scan my systems, and you have to approve that. And with that, I'm at the end of the talk, and I hope we still have some time for questions.
Yes, we absolutely have time for questions. Any questions? You need to press the button.
Okay. Thank you for the presentation. 2 questions. What happens to alarms when they're repetitive? Because it's automatic scanning, so you probably want to acknowledge and not getting this again and again. And I guess what happens to reports? Because you said you build this workflow and it's like outputting to JSONs, but you want to represent this information somehow, and it's different tools, different formats. How do you glue this together? Thank you.
Yeah, so first the question about the alerting, that depends on your alerting system, right? Ideally, you release an alerting system where when it pops up for the first time, and then it's not going to report again. So it's silenced after the first notification. And 2, it depends on how you want to report. So sending to Slack is one way of doing it in a Slack team channel. The second option is you send Slack message to the person who owns it. Third option, you send out an email. And the fourth option, you create tickets automatically when you have the asset ownership information. And the fifth option, I mentioned the document, there's a spreadsheet or a Word document, but these are more for internal reference. They are not really used for the end user here being the owner of the asset.
Any more questions?
Yes. Sorry. One question. How big is your organization? How big is your team? And how many in your team can manage this? It's not a nasty question. I'm working on this, and I know how much time it costs me. And I'm not so far as you are.
The organization has 300 people. The security team has 3 people.
Okay, thanks. And how many of these 3 are working on this? Have the 2? Okay, thanks.
But to continue a little bit, if you have a problem with the operational overhead, there are also as-a-service offerings which make it easier for you.
No, understood. Perfect. Thanks.
Thank you. I want to ask how to deal with shadow IT or non-manageable IT that's not directly managed by the central IT. If you are working in an engineering organization and engineers like to do stuff themselves because they know better, how you deal with that?
Yeah, it depends on where these assets are located. If they are in the cloud, you can directly read them, right? That's the easy part. The problem is classical data centers. And first you have to, if you don't know this exists, then you have a problem. There's nothing you can do. What happened here is when they are requesting resources like in a data center, it goes via IT. So IT is the point of contact for that because they know everything. So I'm only grabbing the address ranges and that's it. If there's 10 machines sitting there or 100, it doesn't make a difference. It will be automatically scanned. But you need a partner in the organization who really knows where the assets are located.
We do have time for one more question. Otherwise, I guess you're around at the conference for some discussions. Zum ersten, zum zweiten. And that's it. Thank you very much.